Hello, everybody, and welcome to the Crypto Hipster Podcast. This is your host, Jamil Hassan, the Crypto Hipster, where I interview founders, entrepreneurs, executives, thought leaders, amazing people all around the world of crypto and blockchain. And today I have another amazing guest, and he is the CEO of Arithmic. His name is Karan Bhardwaj. Karan, welcome to the show.
Thank you for having me, Jamil. It's good to be on here.
You're very welcome. I almost said arithmetic, but it's arithmetic. So
Yes, very close.
very close. Welcome. Thank you for joining me and kick things off. And the first question I ask everybody pretty much is, what is your background? And is it a logical background for what you're doing now?
I think it is. I've been in the blockchain space since 2016, 2017. I've When I started working in blockchain, I happened to start working with a company that was building out a protocol as well, which is a base layer network. And I've always had my heart or always had my interest in building at that layer. Since then, I've had the opportunity to build out dApps, slightly more centralized applications that do connect to deeper protocols. But working at the base layer, at the protocol layer, has always been something where the heart has been. Right? I did my undergrad in physics, and physics is essentially a fancy, or not so fancy, but essentially math. And there's a lot of supplementary maths that you also need to do. And when I first came across proof systems, which are sort of what ZK rollups or Validity rollups are built around, I suddenly could see the potential for a lot of problems that I'd faced, whether working at the protocol level, whether working at the application level, or working at uh, the dApp level, of different kinds of bottlenecks. And when I came across this emerging technology back then, I realized that this had the potential to bring scale and a lot of economic opportunity to the blockchain space. And that's when I, raised some money, started building, and it's been 2.5 years roughly since we've been building. And I think there's something very robust and exciting that's coming up soon.
Very cool. So, what is Arithmic all about? What do you guys do well? And what is your definition of a layer two native scaling network?
Okay, so uh, over the past couple of years, a bunch of different L2s have entered the blockchain space, right? Whether for Ethereum or for Bitcoin. A native scaling L2 or a native staking L2 is one in which, as people lock liquidity or they deposit liquidity into the layer 2 for all kinds of reasons, they're able to generate a native yield on whatever asset that they're depositing, right? So, and because we are a layer 2, both for Ethereum and Bitcoin, we implemented a fairly unique system of generating yield across multiple different assets. And that's sort of something that, I'm looking forward to discussing more with you.
Yeah, let's talk about it. Before we get into ZKs, I want to talk like I don't know if anybody else is a layer two for both Ethereum and Bitcoin, right?
Hmm.
How do you do it?
Yeah.
How can you be both?
So I think that it's much harder to be a layer 2 for Bitcoin because Bitcoin has no EVM or VM, not EVM, no VM, no virtual machine, no scripting on its side. There is a scripting language, but it's a little bit primitive, and you can do far fewer things. And the amount of data that you can store on the Bitcoin layer 1 or the Bitcoin network is very restricted, right? Uh, and so running a verifier on Bitcoin layer 1 is not practically possible. So, which is why naturally all layer 2s initially targeted Ethereum, right? And over the past year, year and a half, there have been some paradigms around bridging mechanisms from Bitcoin to layer twos that are sort of beginning to enable layer two networks that can scale Bitcoin. So the things that we implement on the Ethereum side are more in for the industry, are slightly more evolved than on the Bitcoin side because of certain challenges that the Bitcoin network uh, faces up. But the way in which Bitcoin L2s today are positioned, a lot of them are built or proposed around BitVM, which in our opinion will take some time. And there are some unresolved questions that at least we can't see the answer to with regards to slashing, etc., on the BitVM side. So we've come up with our own fraud-proof mechanism or our own implementation of a fraud-proof mechanism that works a little bit differently than BitVM. We're going to be out with our white paper soon on that, which will focus purely on our BTC to Earthnic, bridging layers, etc. connection. And on the Ethereum side, we build a slightly different kind of zkVM network as well. So I'll talk about that with more questions from your end.
All right, so let's go down the Ethereum first because most people understand that side first. I'm going to come back to the Bitcoin side because there's some tools and I want to understand how it works. And I know you work on the white paper and probably, I don't want to release any trade secrets, but I do want to understand it. So let's talk about Ethereum first. You have dual innovation of ZK VMs and ZK ASICs, right? So how do they work together to unlock new opportunities in liquidity?
Sure. So I'll talk about the ZK VM first, right? So the way we talk about our ZK VM is that we call it a Gen 2.0 ZK VM, which essentially means it's a second gen ZK VM. The existing larger networks on the ZK front, those we like to look at as Gen 1.0 ZK VMs. Now, I'll very quickly differentiate between the two. When you run a validity rollup or a ZK rollup, what you are essentially doing is you're taking a bunch of transactions off of layer one and processing them on layer two. Not only are you processing the base transactions, you're also doing a lot of mathematical computation on top of it, where you turn it into different representations, etc. All of this adds computational overhead. Sometimes the computational overhead can be as high as 20,000x on a single transaction. So essentially, on layer two, you're doing a lot of extra computation than you would do on layer one, right? Now, the older way of building out ZK VMs was to do a lot of this overhead, like actually process a lot of that overhead. But sometime in the middle of 2023, a researcher by the name of Justin Taylor, he came up with the Lasso Jolt paradigm. You may have heard of it. They've recently gone public with an implementation of Jolt. Now, we started building sometime last year on this paradigm. And this essentially replaces a lot of overhead computations by extensively using what are called lookup tables. And so all of the computation is, in a way, we reduce the overheads on layer two drastically through using these kinds of. So that's a major, and I think that we're probably the only network that's close to going live built on this paradigm. But we believe very strongly that this is the future that Validity and ZK rollups will take, rather than the Gen 1.2 path that they have been taking or they have built around. So that's on the ZK VM front. And the numbers that we're seeing are actually they're very good. And some of the newer system that we've implemented, those numbers are even better. So the older system that we had, the internal testnet that we were running, that was seeing between 50 to 100 TPS, and now we're seeing even higher than that, almost touching 200, 300 effective TPS, right? So on the pure VM, just the ZK VM front, this is what we are doing differently. And eventually, in the ZK space, as protocols, essentially all of these layer 2 protocols, as they stabilize, we will require custom hardware to essentially accelerate computation on this layer. As I mentioned, there's a lot of overhead computation that we do to ensure that processing of transactions is happening in the right way. And I think if ZK rollup layer 2s really want to be the scaling solution for blockchain, they must have much better performance than layer 1, which we don't see today. And this is partly mitigated today by throwing a lot of firepower at these networks. So you have very high compute being thrown at it. But over time, I think custom hardware that sort of makes these far more efficient, makes the proving process far more efficient, makes the verification on layer 2 much more efficient, perhaps certain kinds of validations, that will bring another level of efficiency and scale to layer 2 networks. And so that's where the ZK6 comes in.
I understand all that. I think it's a good point you make. Mapping tables are my thing, or were my thing when I was a SQL builder dev in corporate America. We would take the stuff out of the code, build mapping tables, and that would make everything run more efficiently, including bring down the costs. So that makes perfect sense to me.
Yes.
So I like the Ethereum side. The Bitcoin side, other tools that have come forth in the past few years, Lightning Network, Taproot, how are you building that, layer 2 on Bitcoin? Are you using any of those tools, or are you doing something completely unique?
So essentially, we should understand where the challenge is, like where really the challenge is in building a layer 2 for Bitcoin, right? So getting Bitcoin from the Bitcoin layer to a layer 2, that is not so complicated, right? That can be done honestly and in a decentralized manner. Getting assets back from layer 2 onto layer 1 or distributed to the right people on layer 1, that is where the challenge is, because there's no smart contracting on the Bitcoin side, right? So what used to happen in the past is that people would run multi-sig bridges. And when they would run multi-sig bridges, not fun things would happen because they would get compromised often, right? So whether it's whatever functionality that Bitcoin and the Bitcoin scripting language has, we obviously have to use all of it. But the bridging mechanism, which is built around a fraud-proof mechanism, that is what is being innovated on today. Right. So it's that direction, so that when assets are being transferred from layer 2 to layer 1, it's happening in a decentralized manner and happening safely, basically.
And that's where your trade secret comes in that we're not going to tell the world yet, right? It's a one, right? Unless you want to.
So essentially it's a fraud-proof mechanism that's going to look similar to how it's done currently, but instead of the operators behaving in the way that they operate today on BitVM, they'll behave slightly differently in our paradigm. So with liquidity, with how we sort of create economics around that liquidity, those systems are different, and the fraud-proof mechanism is also different. So this is some of the things that are going to be different from BitVM.
Got it. Sounds good. So we have these multi-chain bridges, and you enable multi-chain staking pools, so you can use multiple chains to pools, right? What are the advantages of multi-chain staking pools? And I'm assuming that you're going to build not just opportunity for Bitcoin and Ethereum, but for others as well.
That's right. So I think layer 2s, and especially ZK and validity layer 2s, they require a lot of computation. right? So we require provers, we require verifiers, we require validators, we require operators, we require many different. If there is some computation that needs to be done in the blockchain space, some variety of it is being done on layer twos, right? And the way that almost all layer twos, including us, guarantee security and safety is through staking. So all layer twos essentially run a form of proof of stake mechanism to ensure that the participants on the network are behaving honestly, right? And this staking mechanism naturally generates yield because there's no other way to actually do the staking, right? And as we were thinking about, because essentially yield has been, and yield-based economic systems are not new for blockchain, but new, I mean, they're like a year and a half that we've been talking about it. In blockchain, it seems much longer because things move quickly. But we thought that as a layer two, we want to attract a variety of liquidity on our network, and users essentially hold onto liquidity with the hope that yield is generated for them. And there is a very strong requirement for securing our network against malicious actors, which requires liquidity. So we felt a very natural this ability for multiple parts of the network to come together and facilitate operations that essentially are good for everyone. We call it aligning incentives across retail or institutional end users, infrastructure partners, and developers and other projects. So we look at it as aligning incentives. And instead of purely focusing on our own token, we allow for a basket of tokens to come in and secure our network against, or secure our network essentially, right? And based on that securing, we generate yield and a higher yield compared to other L2s that sort of are also looking in this direction. That's why we decided to go the multi-chain pool staking.
You get higher yield because you're reducing the risk.
So one of the things that, because we connect to L1s and multiple L2s, we run infrastructure anyway. And when we run infrastructure on other proof of stake chains, we are able to access yield from those chains as well. So not only do we pay out yield from our chain, but we can pay out yields from other chains. And with the explosion of LSTs, basically liquid staking derivatives, we accept those into our pools as well. The more stable projects, we are able to sort of provide a higher yield basket, including from our own.
What are some examples of liquid staking derivatives?
So you have Lido, which is one of the major liquid staking protocols that's out there. I can talk about liquid staking for a bit if you wish. So essentially what happens is that on chains like Ethereum, the consensus process is supported by a large number of validators. And to run validators, you need to deposit a certain amount of ETH to participate in the consensus process, right? And for participating in the consensus process, you are given rewards back. And that really is where the yield comes from on Ethereum, right? And because the amount you need to stake is quite large, multiple protocols have come up, or multiple projects have come up that pool ETH together, and then they partner with the infrastructure providers and they run validators. And when you stake with these essentially pooling protocols, etc., they issue a token back to you. That issued token is essentially called a liquid staking derivative. And then, of course, you can stake that back, and then you have another layer of that derivative.
That makes sense. Okay, thank you. You mentioned incentives, and you mentioned the different players in the ecosystem, in the protocol, right? And often the incentives of the core participants in a blockchain network are misaligned, right?
Yes.
All the time, right? What can we do about it?
So first we have to understand where the misalignment is, right? The misalignment is from the retail user, from the customer, or the people who just want to trade. Uh, Projects to attract any kind of retail investor throw tokens at them essentially and saying, we call them airdrops. So they say, take these tokens, hold them for a while, price will appreciate, and then perhaps you won't dump as much. That's sort of what projects say to retail customers, right? And then on the infrastructure side, they talk to these large companies, infrastructure providers, and they say, look, run these machines to secure our network, to sort of run our nodes, and we'll pay you in our token, and then you can sort of figure out whether that's economical for you or not. And on the other side, for developers and for larger projects that would build on your network, we again have a similar kind of relationship where we say, take this money, build here, and we'll attract users, we'll attract infrastructure partners, and we'll have like a decentralized network for you to operate on. So this pulls networks in three different directions because the incentives themselves are not aligned. Now, when we talk about retail coming in or customers and consumers coming in with liquidity, they come in with the expectation of earning yield. When we have infrastructure partners who we can attract to the network, they come in with the expectation of also earning money, but also with the liquidity barrier that they face, right? So at once we can align incentives for customers as well as infrastructure providers, where stake is provided for securing the network, yield is generated on that stake that is securing the network, distributed amongst the customers as well as the infrastructure providers. And the infrastructure providers begin to then provide their computation services. And to facilitate all of this, we have a layer of application builders, developers, and projects that also participate in this yield activity. And whether it is to facilitate the users getting access to this, or whether it is to build on top of it to sort of enhance these capabilities of the network. And so this, for us, aligns the incentives of the three kinds of participants, broadly speaking, that we want on our network. That's sort of what we mean by aligning incentives. And this literally generates new economic activity, new liquidity. And it allows for the creation of course, in the blockchain space, the appreciation of the token is a major way of value being created. But this allows for a new level of decentralized economic activity, where we are very organically aligning various participants on the same network.
I like the alignment. I'm looking at a hole in the alignment. Say you have everything aligned. Say all the incentives are aligned, and the people coming with liquidity are receiving airdrops, right? And there are bots out there who are providing no liquidity, yet they're getting multiple airdrops, and then they're robbing the liquidity of the end user who brings liquidity in, right? So how do you deal with those external factors, external risks that tear down the security of your alignment?
Great question. So the existing airdrop models have always rubbed us the wrong way. We've never been comfortable with the way that airdrops have functioned in the past. So the way we do airdrops is that we pay out airdrops, or we sort of distribute airdrops within the pools themselves. So rather than handing out tokens to random wallets based on certain conditions, in the multi-chain staking pool that users are staking their various tokens, we distribute airdrops through these pools in the form of returns themselves. So in that way, the activities that they need to perform in order to get airdrops are all tied to the pool. And so bots don't really come into the story here, because we're not sort of incentivizing actions that bots would perform and giving airdrops. Rather, we are baking it into the multi-chain staking pools themselves.
That makes sense. That's a good idea.
And in fact, in the future, what we also want to do is we want to encourage other projects to execute their airdrops on our network through this mechanism, so that you have users who are while still participating in the way that they do in the blockchain space, but you can give out airdrops to people who are actually performing actions or in the right way.
I like it. I like it. Very cool. So, I went to, I don't know if you had this opportunity to go to Consensus in May, in Texas.
Not this year, but we are going to be at EthCC.
Okay, very good, very good. What I learned was that we still have fragmentation in the industry, right?
Yes.
Still have people who who are Bitcoiners who call every other coin a shitcoin. They're not, but we need to stop being tribal.
Yeah.
we need unity.
Mm.
How can we knock down the silos and become unified?
I think that so Bitcoin maximalism has been around for a while, and personality-wise, I like them because they are very, very libertarian, and it's an interesting way of looking at things. And I think that as you move further towards the L2 stacks, less tribal and more constrained by these fairly complicated systems that people have cobbled together, right? Because L2s are fairly difficult to build out, and building out decentralized L2s is even harder. And the more you go in the ZK direction, building out a decentralized ZK network where people can just connect their nodes, start generating proofs, start verifying, etc., that is an incredibly hard problem. And one thing that has always stuck with me throughout my journey in the blockchain space is that no matter how dedicated the developer team is or how dedicated people are, people usually don't like to run infrastructure, their own infrastructure, right? And which is why companies like Infura do so incredibly well, right? And so it's like this very difficult problem that you build out your network and it's difficult to decentralize it. So it ends up being a silo no matter what you do. And then, a lot of bridges, etc., need to be supported. But it's a organic problem, is what I would like to point out, first of all. Second, I think that over time, for the end user and end customer, the siloed nature, even if it continues to exist on the tech level, should become invisible. And it should almost be like a landscape of multiple projects, multiple actions and activities that they want to undertake without sort of having to manually connect to these silos, which is essentially what the situation is today, right? And I think a deeper interoperability between layer twos and especially with the Bitcoin ones that are coming up will be essential in sort of making sure that not liquidity flows evenly, but access to liquidity is more even.
Very cool.
There's an additional problem on the validity rollup side, which is economic in nature. So ZK rollups and validity rollups, these aim to reduce the transaction fees for Ethereum and Bitcoin in the future. And the problem with trying to reduce fees to almost nothing is that it's not a lucrative activity. And so there are no fee mechanisms or fee markets that are lucrative for ZK rollup companies or validity rollup companies. So that is also another reality. And I think that is necessary for a scaling layer, uh, to have some kind of economic activity that is sustainable, essentially. And so all of these problems sort of come together and create what you see today, a very fractured blockchain landscape. But I will say it's less fractured than in the past. I will say that. It's just that there's much more money in the system. In the past, we probably didn't even think about this fracturing, but the fracturing has always existed.
I like that word fracturing. I this is my seventh season, right? I come out of season 6 in March. I'm like, I think I know a lot of this stuff now. And I start talking this season about ZKs, about infrastructure, about and I see I'm like, I don't know anything like I thought I knew, because there's so many smart people now building really fractured, complicated stuff. So like, it's pulling my brain every day, which is good. I get to learn. But it makes it very, 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 very confusing scaling landscape globally, right?
Yes.
So I want to get your thoughts on what the ultimate path forward is for scaling, because it is so fractured right now.
I think that for the ZK/Validity rollup landscape, I think layers that are able to multifold or process multifold of Ethereum's daily TPS or throughput, that is crucial for us, for the ZK space to be a genuine scaling layer, right? So that's something that would be very necessary. The optimistic rollups do have better numbers, but we also look at optimistic rollups as a sort of path in the evolution for layer 2 for multiple different layer 1s, right? And so I think it's very necessary for us to mature as protocols. So we need to have a very mature protocol around ZKVMs, ZKVMs, move towards the whichever type of VM that is like the right balance. So the protocols need to finally crystallize a bit more. That's the first necessary step, right? The next necessary step is, in my opinion, on the technical side, on the technological side, is in the direction of stabilization of hardware. So hardware also has many intermediate steps. It's incredibly difficult to build hardware, and it's extremely difficult to build ASICs for these very complicated protocols. Right? ASICs are essentially, you may remember from the Bitcoin mining ASIC heyday, Bitmain, etc., who would build ASICs for the hashing algorithm for Bitcoin, right? But now, when you talk about ASICs for proof systems, that becomes multifold more complicated and expensive, right? So there are intermediate steps. So for example, we are currently building out FPGAs, what are called FPGAs, which is like an intermediate step between, you can think of it as an intermediate step between ASICs and what is called general compute, meaning so normal servers, essentially normal CPUs and GPUs, right? And what we do is, let's say the protocol has 5, 6 parts. Certain parts are bottlenecks, right? Even for layer 2. And so those certain parts we offload onto hardware. And so the evolution of hardware to support stabilized protocols is probably going to be what is necessary on the, for ZK and Validity rollup layer 2 networks to begin to stabilize more. So that, I think, on the technology side, that's what's necessary.
Interesting. And is that something that like the video would work on, or Microsoft? Like who would work on the evolution of these ZK ASICs?
So I think it would be great if some of the bigger chip producers would work on this, but I think they would face similar challenges as the ZK companies face today, which is instability on the protocol front. So every few months, there's very big changes, right? I'll give you one example. About 2 years ago, we all thought in the ZK space that recursion would bring a lot of scale to layer twos, right? Recursion would do it. But what ended up happening was that there were significant overheads at every level of recursion as well. And so that sort of ended up mitigating. Of course, everyone still uses recursion in varying degrees in different ways, depending on your commitment scheme. But every few months, we sort of evolve a bit as as a subsystem or an ecosystem in blockchain, right? And till we get to a slightly more mature point where front-end systems, the back-end systems, storage, how we connect to networking, how we do the sequencing, till these systems are slightly more mature and they're able to get scale, it will be much harder for these bigger players like NVIDIA or Microsoft to also step in and make these protocols.
Okay, got it. I think I'm gonna go to the next ETH conference. I don't know when that is, but I think I gotta go. So,
Yeah.
you know, and then the Bitcoin mining conference next year, I'll go to that. I think I did need to be around this conversation of the development of hardware a little more than I have been. So, I want to thank you very much for your time today. I learned a lot, and I look forward to seeing what you guys are doing next, and your white paper, and read that. So, and I have one last question. Is how can people find out more information about you, about Arithmetic? If they have any questions or want to research into you further, how can they do that?
So we have our website, we have Twitter, we have our Discord. So people can just look for arithmetic.com, and they can sort of find our Discord. Discord is live and open, and we're looking forward to chatting with people, which we already do. Then we've ramped up our activity on Twitter and Telegram as well. And so those are another two mediums on which we interact with people and sort of share what we've done so far. We have a light paper that's already out. That's on our Gitbook, which is also accessible through our website. And soon we're going to be out with our BTC paper and a larger yellow paper that we are working on as well.
Awesome. Thank you very much for your time today.
Thanks so much, Abel. Thanks for having me.